Hello everyone, my name is Amy Hergott and I'm a graduate student supervised by Colin Whitfield and Helen Balch, and I'll be talking about nitrogen recycling in prairie potholes. As many of you know, this region stretches across the 3 prairie provinces and dips into the United States. It was formed by retreating glaciers which left millions of small depressions or potholes. It also left a very productive landscape, essential for food production in this province. Saskatchewan has become an agricultural powerhouse, exporting over 12.9 billion in agri-food products a year. I'm sure almost everyone has seen the colors of harvest driving along a rural road or bought local products like meat, bread, or vegetables. We have achieved this level of production through technology, innovation, and understanding basic plant needs. And one of those needs is nitrogen. Nitrogen is often applied as a fertilizer to increase plant growth and yields, which is great. But when nitrogen is found in high concentrations on the landscape, either as an applied fertilizer, manure, or other forms, it can become very menacing. With a changing climate, severe rain events may become more frequent, washing that nitrogen off the landscape into nearby water bodies, where it can then accumulate to dangerous levels, leading to eutrophication, degraded water quality, and creating toxic conditions for humans and animals. But wetlands can act as a buffer and trap these nutrients before they pollute major water bodies, such as rivers, lakes, and drinking water reservoirs. Unfortunately, the prairie pothole region has lost over 70% of wetlands in some areas, largely due to agricultural activities, which means the services that go along with these wetlands have also disappeared, such as capturing those nutrients before they reach vulnerable water bodies. The limited amount of potholes on the landscape highlight the importance of understanding the nitrogen pathways within these ecosystems. Potholes are actually very complex ecosystems. They're capable of harnessing and retaining excess compounds, such as pesticides, nutrients, and harmful metals, preventing them from being exported into adjacent water bodies or ingested by humans and animals. In studying these processes, we can develop more robust nutrient budgets, restore habitat, and improve our understanding of the nutrient pollution thresholds of these ecosystems. The processes that we'll be focusing on today are dissimilatory nitrate reduction to ammonium, or DNRA, and phytoplankton uptake. These 2 pathways are exceptional teammates. The process of DNRA takes nitrate and reduces it into ammonium. This ammonium, along with nitrate and urea, can then be used by phytoplankton and converted into organic matter, transforming it into a less mobile form, removing it from the inorganic nutrient pool. In the heart of the prairie pothole region is the St. Denis Wildlife Area. This area is devoted to research on waterfowl habitats and wetland ecology, and features over 200 wetlands of varying size, permanence, and salinity, among other characteristics, making it a perfect study location for my research. What I have found so far is that these potholes can be very productive. We have the rate of DNRA on the y-axis in micrograms of nitrogen per gram of sediment per hour, with incubation period on the x. At ambient concentrations, there was nearly no DNRA activity, but after a spike of 1 milligram per liter, we saw a very notable response, a good indication that our potholes are very efficient at harnessing nitrogen during periods of influx. Phytoplankton uptake was also very productive in these systems. This plot displays the rate of uptake across seasons for each analyte studied. We have uptake on the y-axis, while analyte is across the x, and we can see that in summer, the rates of uptake skyrocket, especially for ammonium and urea. The maximum uptake rate was nearly 20,000 micrograms of nitrogen per liter per hour, which is crazy. We can also see that in our cold seasons, though the rates are significantly lower, there is still activity worth noting. And so in summary, potholes have proved to be a very powerful force in harnessing excess nitrogen. They are very important players on the landscape and can help protect our water resources and our health. A deeper dive into this data includes assessing the roles pond permanence plays on productivity, the role denitrification may play in removing nitrogen from the system completely, and exploring common pothole characteristics to better understand what influences these rates. With this information, along with the information gathered from fellow colleagues, we can begin to develop better modeling and resources to better our wetland management and increase the resiliency of our prairie pothole region. Thank you.